Anyone who's ever done research out in the field knows that your biggest opponent isn't the equipment or the long hours, it's the weather. And that's especially true when your work involves taking pictures, say to check the health of turf grass on a golf course, because one cloudy day can throw a massive wrench into everything. See, when you're snapping hundreds of photos to build a detailed map, the last thing you want is inconsistent lighting. It's a total nightmare. As clouds roll by, the light changes, and that messes with the color and exposure in every single shot. And this isn't just about pretty pictures. It can seriously mess up the quality of your scientific data. So that leads to the big question, right? How can you trust your data when the conditions are changing from one minute to the next? How do you get reliable results when your laboratory is, well, the great and very unpredictable outdoors? So let's dive into this challenge of clouds. The real problem is how the sun's intensity is constantly shifting, which directly impacts how the camera sees the world. Now, you're probably thinking, wait, don't cameras have automatic settings for that? And yeah, they do. The GoPro used in this study was actually set to auto-adjust the exposure. But even with that, when you have these huge swings between bright sun and dark cloud cover, it's just not enough. You still get images that are way darker or lighter than others. It's not a perfect fix. Okay, so if the camera itself can't quite solve the problem, what about software? Maybe there's a digital solution waiting for us. The tech we're talking about is called Structure from Motion software, or SFM for short. What it does is pretty amazing. It takes all those hundreds of individual photos and, like a super smart digital quilter, it stitches them together into one massive, incredibly detailed map. This final product is called an orthomosaic, and that's the thing researchers actually analyze. And here's the magic part. This software has a built-in feature, literally a single button, that promises to fix our lighting problem. It adjusts the brightness and saturation across every single image, trying to make them all look uniform before it stitches them together. I mean, on the surface, that sounds like the perfect answer, right? But, and this is the million-dollar question for any scientist, does this easy one-click fix actually make the data better? Or does it just make the final picture look a little prettier, a little more even, without actually improving its scientific accuracy? Well, that's exactly what this experiment was designed to find out. All right, first things first, let's just use our eyes. What do the results look like? How different are the two final maps, the one with the fix and the one without? Okay, what's wild here is just how similar these two maps look. On the left, we've got the map made from the original photos, no changes. On the right, the map from the fixed photos. At this bird's eye view, you'd have a really tough time telling them apart. Let's zoom way in on just one small section to get a better look. Again, original is on the left, the adjusted one is on the right. Can you spot the difference? I sure can't. Visually, it looks like that adjustment feature did next to nothing. So, if we were just going by what we can see, we'd probably say this feature is pretty useless. But looks can be deceiving, and in science, the real story is always in the numbers. It's time to stop trusting our eyes and start looking at the data. So, let's dig in and see what that one-click fix actually did under the hood. What do the numbers tell us? So here, the software is analyzing one of those plots to figure out the percentage of green cover, basically how much healthy grass there is. In the original image on the left, it measured 55.8% green cover, but look at the adjusted image on the right. That number dropped to 54.5%. It's not a huge difference, but it's definitely a change. So for this specific spot, that one-click fix actually lowered the measurement of healthy turf by 1.3%. And this wasn't a fluke. When they averaged it out across all the plots, the adjustment consistently reduced the measure of green area. But hold on, here's the most important question of all. At the end of the day, we're not just measuring green spots, we're trying to figure out how healthy the plants are. The gold standard for that is a metric called NDVI, which is a really reliable index of plant health. So the real test is, did our fix make our data a better match for that ground truth NDVI measurement? And here it is, the punchline. The software adjustment actually reduced the correlation with that key health metric by 0.69%. Let me say that again, because it's so important. The one-click fix that was supposed to improve the images actually made the data less accurate, a weaker predictor of real-world plant health. So, after all that, what's the final verdict on this seemingly helpful little button in the software?
Okay, let's break it down. First, the adjustment did change the numbers, making the software see a little less green grass. But more importantly, it actually made the data worse, weakening its connection to the real-world health metric NDVI. So the conclusion is pretty clear. The fix didn't improve data quality at all. It's a fantastic reminder that just because something looks better doesn't mean it is better.
And you don't have to take my word for it. The researchers themselves put it perfectly clearly. Adjusting pixel values in the SFM software before orthomosaic image generation likely did not improve data quality. Can't get much more direct than that. And that leaves us with a really fascinating and important thought to chew on. In a world full of automated tools and one-click solutions that all promise to fix or enhance our data, we have to be careful. It really forces us to ask the question, when is a so-called improvement actually making things worse? And how can we be sure that the fixes we're applying are truly taking us closer to the truth?